Okay, bom dia a todos. I will continue in English with the application of our electrochemical process for the removal of persistent, mobile, and toxic contaminants. So to date, like a great number of chemicals have been found in several water matrices globally, and some of them were even detected in our tap water. So how did these chemicals end up in our drinking water? So first of all, they are presented in industrial wastewater or domestic wastewater. And these chemicals, they can bypass wastewater treatment plant and also bypass the natural barriers. And finally, they will end up in our drinking water. So these substances that can cause long-lasting and diffuse contamination of water resource are defined as persistent, mobile, and toxic substances. So to be more specific, the persistence, mobility, and the toxicity of these substances can be assessed by the degradation half-life, log KOC, and the long-term non-observed effect concentration. So who are these PMTs? So they can be everything. They can be pharmaceuticals, they can be PFAS, and they can also be other industrial additives and also products. So, of course, with this big group of chemicals, they have very different properties. For our electrochemical system, the most important two factors are their charge and also their chemical structure. So we will group these chemicals by these two properties. And today I will give you examples of three of PMTs, melamine, phenazone, and TFA. As for the sponge, I will choose polydopamine-doped RGO, which can help to increase the hydrophilicity of the electrode and also introduce diverse functional groups. So first of all, if we don't put any current in our system, the PMTs can be removed only by adsorption. So here, this dashed line is the initial concentration of PMT. And without current, we can see that melamine can be removed more or less like 50% by only adsorption. But with phenazone and TFA, we don't see any adsorption. What if we turn on the current? When we start applying current, we don't see removal of melamine anymore, but we can see the removal of phenazone and TFA. But the question here is, they are both removed, but do they have the same removal mechanisms? So, well, let's turn off the current. When we turn off the current, we can see here we don't see anymore the removal of phenazone, which means here the removal is ascribed to the electrooxidation. But in the case of TFA, we can see a significant recovery, which means here the removal is due to the electrosorption of TFA on the sponge. So these results show us that these three chemicals with different charge and different chemical structure cannot be removed under one single condition. So what we can do if they are mixed in one water matrix? So first of all, we can use one reactor without applying current, and here we can remove melamine by adsorption. Then the effluent can be passed through the reactor with current, and here we can remove phenazone and TFA. So this is just an example of three compounds removal by one electrode. So imagine if we can extend this system, this setup, and for each module, we can use different electrodes to target different PMTs. And also we can apply different conditions. So maybe each module can help us to remove one group of PMTs. And hopefully we will get PMT-free water like after several modules. So to conclude, multi-components electrochemical system can be a promising strategy to target on the removal of diverse PMTs. Okay, that's it. Thank you.